The best way to really understand this is to look at a whole bunch of examples. So what we're going to do is we're going to take the position time graph and then draw the velocity and acceleration graphs. So if we look at this situation here, we have the position of an object and the slope of this line is constant and negative, telling us that the velocity is constant and negative. Again, the slope tells us about the next graph. So what does that mean? Well, if we put a little car, it's starting in the positive position and it's moving back towards 0, and then it's moving into the negative position, and it's doing this at a constant velocity. So its velocity is negative and it's constant. Let's look at the next one. This is basically the reverse of this. It starts at a negative position and ends at a positive position. The slope of this line is constant, so the velocity is constant. It's also positive, so in this case, the velocity is like this. Now, I didn't mention this in the problem before, but the slope of this line is 0, so the acceleration is 0. Same with this one. The slope of the velocity is 0, so the acceleration is 0. This one's a little bit more tricky. The slope of this line tells us about this. The slope is steep and positive, so the velocity is large and positive. But the slope decreases, becoming less and less positive until it becomes 0. So the velocity is decreasing till it becomes 0. Then it starts to increase negatively. So the velocity increases negatively. This is like taking a ball and throwing it up in the air. It has a positive initial velocity, it slows down on the way up, speeds up on the way down. Now the slope of a velocity time graph is our acceleration. So what's the acceleration? It's a constant negative value. So it's this. If this was for an object thrown up in the air, that would be negative 9.8. In this one, this is even more tricky. We have starting out a large negative slope. So this is a position time graph, so the slope is velocity. So the slope is large and negative. It starts here. And what's happening to the slope? It's becoming less and less steep until it becomes 0. So the velocity is decreasing until it becomes 0. Remember, negative velocity just means the direction. It doesn't mean, this does not mean speeding up. This is actually slowing down. Then it starts to get steeper and steeper and steeper, meaning that the velocity is becoming larger and larger. This is a positive slope, so it becomes that. Now, the slope of this line the entire time is constant, and it's positive. So the acceleration is constant and positive. Okay, this next one is technically impossible at this point, but I'll discuss that in a second. So we have a constant position change. So the slope of this line is negative, and it is constant. So our velocity is negative and constant. Now, at an instant in time, it becomes positive and constant. So there actually has to be a little bit of curvature in the real physical world there. So there would be a moment of extreme acceleration there, and then it becomes constant and positive. So if that happened instantaneously, we would actually have an acceleration that would be infinite, but it would be a very rapid positive acceleration, and they're never really going to ask you about that. Number 6. Okay. When we start here, the slope of a position time graph is velocity. It's 0, so our graph begins at 0, and it becomes steeper and steeper and steeper, and eventually it gets to its maximum value. Actually, kind of depends on whether this line is straight here. Let's say this line becomes straight for a little portion of time. So it eventually becomes constant. So it would go up and then be constant for this time period right here. And then the slope starts to change until it becomes 0. So this would drop down like this. So the velocity time graph is our acceleration. Our slope is positive. So our acceleration is positive and constant. Then the velocity is constant, so our acceleration becomes 0. And then our velocity time graph slope is constant and negative, so our acceleration becomes constant and negative. Number 7, for this section I drew it a little better. This is a nice constant slope, so our velocity is constant and it's a negative slope. So our velocity is constant and negative. And then the slope starts to decrease to 0. So our velocity decreases to 0. If you start to see the pattern here, you just look at the slope to get this. You look at the slope to get this. What's the slope here? It's 0. And then it becomes positive and constant. And for the last one here, we have a slope that starts at 0. So our graph begins at 0, and it starts to become steeper and steeper and steeper. So our line negatively steeper and steeper. So our velocity is increasing in the negative direction until this line becomes at a constant rate change. So that's a constant velocity and it's negative, so our velocity becomes constant and negative. So over here we have a negative slope that's constant, that's a constant acceleration, and then this is not changing, so the slope is 0, so our acceleration becomes 0. Let's look at a couple of very tricky ones. So in this case, we start out with a position time graph with a large negative slope. So we start here, and that slope is decreasing to 0, so our velocity decreases to 0. Then it increases, gets steeper and steeper, until the line becomes constant, no more curvature, and it's positive, so our velocity graph looks like that. So what would our acceleration be? From here to here, the velocity is changing, it's positive and constant, so our acceleration graph looks like this, until it planes out and the velocity becomes 0, or the velocity becomes constant, so the acceleration becomes 0. In this one, we have position is not changing, so our velocity is 0 to start. Then it's curving, so the slope is increasing, so our velocity is increasing. And then eventually the line becomes constant, the slope becomes constant, so our velocity becomes constant. And then we have this period of time where the slope is decreasing, so our velocity is decreasing. And then it becomes a constant slope here of 0, so our velocity becomes 0 at the end. So what would our acceleration look like? Well, there would be no acceleration here. An increasing slope here means that we have an increase in velocity here, so that would be a constant positive value. And then it's going to drop to 0 because the velocity is not changing. And then finally, we have a negative slope, so a negative acceleration. And then it stops, so the acceleration goes back to 0.